For our next unit, the first part has to do with square roots and perfect squares. So a perfect square is a number that can be represented as a square. So for example, 1 can be represented as a perfect square. The number 4, if I were to have 4 tiles, I can arrange those 4 tiles into a perfect square. 9 is also a perfect square. If I had 9 tiles, I can arrange them into a perfect square. Okay. So perfect squares are things like 1 times 1, or 1 squared, is equal to 1. A 2 by 2 square, or 2 squared, equals 4. A 3 by 3 square, also known as 3 squared, equals 9. So all of your perfect squares are your doubles, if you remember your doubles from elementary school. 5 times 5, 7 times 7, 9 times 9. Any of those products would be a perfect square. The square root is the number that is getting squared. So for example, the square root of 9 is 3, because 3 times 3 gives you 9. Couple of definitions. That square root symbol that I drew earlier is called a radical symbol. Okay. It looks like a division sign, but it has this little extra lip to it. That's called a radical sign. So instead of saying the square root of 9, I could say radical 9. Okay. The radicand is the number inside the radical sign. So in this case, the radicand is the number 9. For our unit, you need to know by heart 1 squared all the way up to 20 squared. You have to know them by heart because you will not have a calculator for this unit. Okay. You also need to know your perfect square roots from the square root of 1 all the way up through the square root of 400. Meaning, if I were to give you the square root of 144, do you know that that is 12? Because 12 times 12 is 144. If I were to give you, 11 squared, do you know that 11 times 11 is 121? This is what's expected from this unit. Why do you have to know your perfect squares by heart? Just like you've had to do in elementary school and middle school, you've had to simplify your fractions. Once you get into 8th grade in algebra, you're going to have to start simplifying radicals. Okay. For example, if I wanted to simplify radical 50, which is not a perfect square, I could break the number 50 into 25 times 2. So the square root of 25 times the square root of 2 is another way of writing radical 50. Now 25 is a perfect square. The square root of 25 is 5. The square root of 2 is not a perfect square, and 2 cannot be broken down any more than it already is. So 5 radical 2 is the simplified version of radical 50. Knowing perfect squares that can go into your number that go into your radicand that you're trying to simplify makes the process just a little bit easier. If you don't know your perfect squares, you could still solve it. For example, there are other numbers you can use to get 50, like for example, 10 times 5. So the square root of 10 times the square root of 5 gives me 50. 10 can still be broken down into 2 times 5. 2, 5, and our other 5 over there on the side are all prime numbers. Once you've simplified it down to all of your prime numbers, that's how you know that you've reached the end of your simplification. Now in this case, I have a matching set of radical 5s. 5 times 5 gives me that 25, or you can see it as if I have a matching set of radical 5s, that whole number 5 comes outside, just like we had the square root of 25 over here. And then I'm also left over with that square root of 2. You will not have to know how to simplify radicals for this year, but this is why we do this unit, because it leads into this. The unit after this has you doing it with cubed roots.